arc length of a parametric curve. So before I give you the equation to find the arc length of a parametric curve, let's quickly review arc length integral, the formula for a rectangular equation. So let's do that. So I will do a arc length. Okay, this pen. Arc length integral for a rectangular equation. So regarding arc length, we have a graph that is a y-axis, that is x-axis, x, and then y, and then we have our arc length, and then let's say this is x corresponds to A, and this one is x corresponds to B. I would like to find the total length, and then they use S represents the length that is integral x equals to B. I don't like to just say A to B. X goes from A to XB, lower limit and upper limit, and then the square root of 1 plus the square of the first derivative, and then this is with respect to x. The entire integrand has independent variable x. And then for parametric equation, so for parametric equations, and then here is the integral also from A to B. From A to B. Okay, the equation is S equals to, and then we are not doing x anymore. That is t goes from A to t equals to B, and then we have a square root of the x and y are now in terms of t, and then we need to have the derivative of x with respect to t square plus the derivative of y with respect to t square. Since this is a plus, you can do a dy dt square plus dx dt square, doesn't matter. So that is a dt, and then the dx dt is also known as f prime of t, and then the dy dt is equals to g prime of t. So you are doing your homework, they should have a parametric equation x equals to some t, y equals to some t, take the derivative of each, and then square them. And then once you square them, I'm sure that the equation is getting more complicated. And then after you add them, the sum, this one will be more complicated. And then there is a big problem. The biggest challenge is the square root. Okay, you have a square root of a pretty much a very big and long expression. You need to do some algebra or use some trigonometric formula like sum angle formula, difference angle formula, double angle formula to do a rewrite in order to get rid of the square root, because with the square root it is hard to integrate. Okay, it is hard to integrate. And then in the next video, I will discuss a pretty interesting example. And then other than this, I need to make sure the parametric curve does not intersect itself within that interval A to B, except at the endpoint. Except at the endpoint. And then how about this? With some more complicated parametric equation, it will be pretty hard to sketch the graph by hand. It's not impossible. It will just take a lot of time, and then plus we are trying to focus on finding the parametric equation, the arc length, right? We want to focus on studying the arc length. It's not wasting like 20 minutes to just get the graph. Okay, I would like to explore this example in this video and also the next video. I want you to graph x equals to, this is a very interesting example, cosine of t, and then plus, oh, not plus, sorry, minus cosine phi t, and then the y equals to phi sine t, and then minus sine of phi t. And then I want the t between 0 and 2 pi. 0 and 2 pi. One of the ways to do it is you use your graphing calculator. How about I will discuss that in the next video, because I don't want to make the video too long. This one, I will just show you a screenshot of how to do this using Decimal. Decimal is a free app. You can just go to Google and then look for Decimal and then just use it on your laptop. You can download the app to your phone and then just use that on your phone. It's way better than your graphing calculator. You also need to study the graphing calculator because sometimes when you are doing an in-person exam, you can't use your laptop, right? You may need to use your calculator. So without Decimal, it is also good to know how to do that in your graphing calculator. That's why you spend more than $100 to buy it. So back to Decimal, I will do graphing calculator in the next video. Normally, we just type y equals to some x or y equals to some y, right? So if you want to graph a parametric, just make each coordinate a function of t and then click on the domain to change it. So what I did was I start from a parenthesis and then I don't type x equals to. I don't type y equals to. For the x, I will just go ahead and then type what x equals to, followed by a comma, and then type y equals to in one parenthesis. In one parenthesis. I don't say x equals to some t and then y equals to some t. That's not going to work. You have to draw one big parenthesis, separate two equations by a comma, and then you type them. And then this one t is from 0 to 2 pi. Once you do this, this will pop up. You can just fill out the blank. And then for the green and the blue, this one is just a rectangular equation. This is equation of a circle. The slope, the radius is equals to 4. And then this is equation of a circle. The radius is equals to 1. This is center at 0, 0, the green circle. The blue circle, the center is at 5, 0. That is standard equation of a circle. You studied that in the past. So I graph two circles and a parametric curve. And then this one, if you tap on this, you can turn on and off of the graph. If you want to change the colors or make the lines bold, on top of the menu, there is a gear icon in there. There is a gear icon. You click on it and then you can change the color. Once you tap on it, you can change the 2.5 to a 6 to make the line bold, or you can use dotted line or dash line. Okay, so that is for Decimal. Okay, so the plan for now is I will just stop the video right there. That is how you graph this using Decimal. And then the next video, I will use some screenshots showing you how to graph that on your graphing calculator. And then after the next video, I will do the arc length. All right, okay, I will see you in the next video.